Whoops. Let's pick a color. There we go. So lesson P7 is solving inequalities, algebraically and graphically. Right now we're going to work with the nice ones. Okay? We're going to work with the nice ones that are what you've been doing since, I don't know, Algebra 1 for sure, maybe even before. But as we look at these, solving these absolute value inequalities, so solving problems like example 1 and 2. There's inequalities, so there's less than and greater than signs. The key with these specifically are absolute value. As we get later on, we're going to talk about quadratics, okay, so the parabola ones. But with absolute value, you have to remember that there are two options. There's two options because in this absolute value, the number inside the absolute value could be positive or it could be negative and it still be the same. And so if you have a less than sign, less than, we're going to rewrite that as an and inequality. And I'll take you through the steps, but an and inequality, you write the first inequality as is, and then the second inequality, you switch both signs. You switch the inequality sign and you switch the positive sign to negative. Okay? That's if it's specifically a less than sign. Now, if you have a greater than sign, do you remember this from last year? If you have a greater than sign, we're going to rewrite it to inequalities, but we're going to use an or statement. Greater than. Are you catching some hints? And so, again, the first one stays as is. The second one changes both signs. Now, with the and statement, we'll talk about the best way to rewrite it, but we can make it happen either way. So, got it? That helps here. Did you catch me saying less than? You know, kind of giving that, I don't know, twang or whatever there to help you remember. And this one, the or is your great or than. Okay? So those are kind of your little clues to help you remember if you need something. Example 1. The absolute value of x minus 4 is, what is that sign?
Less than.
Okay, it's less than 8. Okay, so my absolute value is by itself. There's an inequality. I'm going to rewrite it as 2. The first one, as is, right? Just drop your absolute value, nothing changes. So I'm going to rewrite this as x minus 4 less than 8. Less than means I'm going to put in and. Okay, because that is a less than sign, it's an and. Your second inequality. You always keep whatever's inside the absolute value the same. So in this case, my x minus 4 stays the same. I stated it earlier as I changed two signs. The less than sign changed to greater than, and positive 8 changes to negative 8. Okay, you can solve those, yes? If it's x minus 4 less than 8, then we're going to add 4 and get x less than 12. And if it's x minus 4, I'm going to add 4 and get x greater than negative 4. Now, I will say with an and statement, you traditionally put it together as one. Okay, an or statement, you leave it as or with the word. But an and statement, we traditionally put it together as one. Do you remember this? So we're going to have x in the middle, bigger number on the right, smaller number on the left. And if this is done correctly, both signs are less than signs. Check it out. X less than 12, x less than 12. This is x greater than negative 4, but what happens when you flip the x and negative 4? it reads as -4 less than x less than 12. There's your answer in terms of inequalities. Now, what does that look like on a graph? Okay, didn't exactly do that right, but that's all right. What does this look like on a graph?
Open circles on -1.
Okay, and where's the shading?
Between them.
Okay, my shading is between. Now, I'm going to tweak the open circle comment here in a moment because we're going x less than 12 and we're going greater than 4. So the shading is between them. Instead of using open and closed circles, I'm trying to get you guys using parentheses and brackets, yes? So an open circle uses a parenthesis. Okay, if it's not equal to, we use a parenthesis. If it is equal to, you'll use a bracket. Now, speaking of which, can you write your answer in interval notation? Because we're still using interval notation. Where does my shaded interval start at? -4 with a parenthesis, because it's not equal to, comma. Where does my shaded interval end at? 12 with a parenthesis. So there's your interval notation that I will still be looking at. Okay? Okay, let's look at example 2. We move well, we can get this done quickly, I think. Example 2. What's a change that has to happen here?
You have to distribute the 2.
I don't want to distribute the 2.
Or
Okay, it is going to be an or statement because it's greater or than. But before I set up my or statement,
add the 3.
we're going to add the 3 and get rid of the
Divide
2
by
also. Divide by 2. Absolute value by itself. I want it to be absolute value greater than or equal to some other number. So I'm going to start off, since it's 2 times something minus 3, we're going to add 3. So now it's 2 times the absolute value of 3x minus 2 greater than or equal to 10, yes? Then how do I get absolute value by itself? We're going to divide by the 2. If I divide the left by 2, we're going to divide the right by 2. Absolute value of 3x minus 2 greater than or equal to 5. Notice, did inside my absolute value change? Now that I have absolute value by itself, now I'm ready to write 2 statements. The first statement stays as is. 3x minus 2 greater than or equal to 5. You don't change the first one. Greater than or equal to means we are using the word or. The second statement, kind of like last time, we changed 2 things. 3x minus 2, what's in the absolute value, stays the same. Change 2 signs. Greater than becomes less than or equal to. Positive 5 becomes negative 5. And then we solve. Do your solving. I'm going to add 2. 3x greater than or equal to 7. I did not space this appropriately. If we divide by 3 now, can you handle x greater than or equal to 7/3? I just leave it as a fraction. It's a repeating decimal otherwise, so leave it as a fraction. Carry down your word. What's my word? Or. Okay, solve the other one. Add 2. So 3x less than or equal to -3. Divide by 3. X less than or equal to -1. Now, here's the deal, guys. Inequalities, that's your answer. Okay, this is an or statement. An or statement cannot be written as a compound situation like that. Now, I need a graph and I need interval notation. Do I have time? Maybe. So I'm going to have a negative 1 here, a 0, a 1, a 2. So we're going to have something happening at negative 1. 7/3 is 2 1/3, yes? So 7/3 is going to be right after the 2. 2 1/3. Close enough. Okay, real quick. Greater than, what's my graph doing here? Are you catching this? It's going to go
Both.
out both ways. This is what a typical OR graph does. Greater than or equal to 7/3, we're shading to the right of 7/3. Less than or equal to 1, we're shading to the left. What's different here?
It splits.
It splits.
There's nothing in between.
Yeah. And at negative 1 and at 7/3, we're going to use the square brackets. Square brackets because it was equal to. Okay, on the left, interval notation real quick. This interval starts at negative infinity, and it goes to negative 1. Bracket. Technically, an OR symbol is a U, the U symbol. And then bracket on this piece. My next interval starts at 7/3 and goes to positive infinity. Okay. Sorry, I kind of squeezed that in at the end. You can start looking at homework, but I'll be honest, most of it you're not going to be ready for. Okay? It'll just be a few at the very beginning like this that you're ready for. The absolute value one. So if you want to do those, go for it. Other than that, we will work on notes tomorrow.